Hi, so in this video we are going to see about horizontal pod autoscaler. Let's begin. What is basically horizontal pod autoscaler? You might have heard this horizontal pod autoscaler as well as vertical pod autoscaler, right? Why do we use this and how does this work? And what are different ways to create HPA? All these things we'll see in this section now. Okay, so let me erase this. Yeah, basically there are resources, right? What are all the resources? Mainly they are like CPU, memory, etc., right? So let's say there are node 1, node 2 as the worker nodes, and there is a master node as well. Now there is a load to the node 1 and node 2. There might be lots of applications, app 1, app 2, and so on, which are installed on the node 1 as well as node 2 as well. This might be running so many replica sets and pods or deployments, stateful sets, whatever. So there might be lots of resources running on this node 1 and node 2. Now let's say there is more usage of the CPU and memory on these nodes of all different pods existing. How do we control the CPU usage and the memory usage so that overload doesn't happen? Or there is node 1 and there is pod 1 and pod 2, right? Let me take a different color. And there is pod 1 of node 2 and pod 2 of the same node 2. So user is sending request to both the nodes. Fine. Now let's say there is, after some time, there is more load on the pod 1. Okay. But pod 2 is not having any load, but severely the load is increasing on this particular pod only. CPU usage and memory usage is increased on this pod. Now what does HPA, when you install it, what does it do? Basically it will shift the load to the other pods if they are available, and if they have capacity, it will basically collect all the information of how much load that particular node can bear, so that I can send this extra load which is there on the pod 1 to existing pod 2 that can bear that load, so that all this controlling of the resources request and all will be done by this HPA. Okay. Now let's say, so basically that is the basic understanding of how the HPA will manage resources. Let's say, what is the difference between HPA and VPA, right? HPA, when there is increasing in the load, it will do a horizontal pod autoscaling. That means there is pod 1, pod 2 and pod 3. If there is more load increased on these pods, then HPA will create one more pod, which will be pod 4, so that the load will be evenly distributed. Whatever it is there on these pods will be distributed on this pod as well. So that is the use of HPA. And what is this VPA will be doing? So on the other hand, VPA will not create a new pod. Instead, it will increase the resource load. Like, let's say CPU is of, like, you are using up in the pod 1 as 25%, the VPA will be increasing. Let's say the CPU is totally used and the load is increasing. It will basically scale the pod vertically. That means the pod CPU request limit will be increased, so that even though it increases like more than 25%, this pod can bear, because now the scaling would be like 30%, so it can bear up to 30% of the CPU load. So that is what is the main difference between HPA and VPA. Okay, now we have seen the difference between HPA and VPA. We will focus mostly on the HPA part. Okay, now how does this actually work? The algorithm for HPA is that it is basically mostly focusing on the desired number of replicas. Okay, so what is this desired replicas? Is how many number of replicas of that inside the node it can have. Like, let's say it can have 3 such pods or 2 such pods. How many replicas it has to run? That will be decided based on the algorithm or the mathematical calculation between current number of replicas, and that is multiplied by the current metric and target metric. Okay, so what is our current metric? Let's say it is like 90% is the CPU uses, and target is we need like 60%, and current replicas are 2, so that gives like around 3 pods. Okay, so basically that node can have 3 replicas of that pods is what it is, desired number of replicas. So why is this all required for our problem solving? Because I want to tell you that this current metrics or the target metrics is all coming from one particular section while creating the HPA, that is request. So even if you observe the YAML file, you can go to the Kubernetes documentation and open it, how the HPA is getting created. There you would see a section called request. You can pause the video and check out the YAML file for HPA. So there you will see the section called request over while creating the HPA, right? This is an important part while creating HPA, because the HPA whole mathematical calculation for increasing or decreasing the number of replicas of that pods depends on the on this mathematical calculation, which needs the request section. Okay, so that's why request needs this. That's why I want to tell you about why are we using a request in the HPA. Basically that needs this that is needed because we need to calculate because this is the heart which decides for by the HPA for increasing the replicas or decreasing the replicas. Fine. Now that you have known about this calculation and how will this HPA work, basically I want to show you if you want your HPA to be running in your system or in any system, if there should be a installation of metric server. Okay, so again, what is this metric server? Like, we have seen API server, and we have seen different other components, config maps and all different resources are there. Again, what is this metric server? Why should we use it, right? So let's see now. Okay, basically it works like this. So there is pod 1, and you know that each pod, like pod 1, pod 2, all these will be running on a particular node, right? And every node, if it is a worker node, it has a kubelet installed in it, right? So kubelet will be running, like each node will have a kubelet running on it, right? So this kubelet will know about the resources. This kubelet will know about the resources like CPU and memory. All these information will be known by this kubelet. Okay. And now since this kubelet is having all the information on and it, how does this kubelet get? Again, it might get from the container runtime and other installations, like mainly from the container runtime it will get the CPU usage and the memory usage on that node. And what does it do? Okay, the other installation is like from the Docker container runtime or some container D or cAdvisor, all these things will be there. Okay, and from all these things this kubelet will be getting the information about usage of the CPU and the memory. So now this CPU usage and the memory will be let it be exposed by the kubelet at a particular stats / summary endpoint. Okay, so there is an endpoint which is exposed by the kubelet about that particular nodes, pods, usage of CPU and memory. That is the first point you need to remember. And let me change. Okay. And the second thing, so now that you are exposing the its particular node statistics of CPU and the memory, like that there will be lots of nodes. Let's say not lots of nodes, let's say like there are node 1, node 2, node 3 and node 4, like that, like multi-node system is there, and all these nodes will have its own statistics, right? In production there might be lots of nodes, so from there each node will have some statistics of CPU and memory. Right. Now that each node is having CPU and memory details, now all these will be gathered by the kubelets and they will be exposed at a particular endpoint, like stats, summary, all these will be like 1 or /2, all these things. Now there is a metric server, right? So that is the second point, which is metrics server. What does this metric server do? It will act like a central repository or something like that, so that it will poll to this stats / summary URL, and it will get all the details of on that endpoints of CPU and the memory, okay, of all those nodes. Now it will again expose that to a particular endpoint, like collective information of all those CPU and memory will be stored at an in memory. Okay, so again it doesn't retrieve the old data, it will have an just the recent data. Okay, recently collected information of CPU and memory will be stored, and that will be stored in the in memory. Okay, it will not use etcd, not etcd, just in memory. Okay, and now let's say if someone is asking, now what will this do? It will collect all this information and will expose it to, let's say, some API / metrics /k8.io. okay, it will expose it to that URL, and it will communicate to the through the Kube API server via Kube service. Through an Kube API service, it will basically expose it to the Kube API server, this So it will tell that okay, please navigate the request to this URL. If the request is coming related to the metrics, navigate it to the URL. That is what this metric server will do. Now who is actually asking this information? Who will ask metric server to tell or get the information of all the nodes? Let's say you want to use like kubectl top of pods, okay, or top of nodes. Now this commands will give you all the CPU and memory information of the all collective information of all the pods and the nodes. And how will this happen? Only if you have metric server installed in your system. Metric server installed in your system, then only you will be able to get the information. So there should be, you in order to use this commands, you need to have a metric server. So if you run this command, no, it will hit the this particular API service via a Kube API server, and this will poll the particular kubelets. Okay, the thing which I got the information is for every 15 minutes the metric server will gather the information of the CPU and the memory of all the nodes and the pods. So for every 15 minutes. And now since you have gathered that information in via metric server, and you have placed that inside some using an endpoint, so whenever these commands are run, right, so then it can gather that information from this particular endpoint is what it is happening. Now using this information only you can build the HPA or horizontal pod autoscaler. So what will happen here is it will be again watching the Kube API server. Okay, so what happens here is that HPA will basically ask the API server like give me the CPU and memory usage for every 15 minutes, it will ask. Okay, and so it will gather the information, and sorry, not 15 minutes, I'm really sorry, it's 15 seconds. So for every 15 seconds it will ask to a API server that okay, please give me the CPU and memory usage. That way it will be monitoring. Okay, HPA basically is for monitoring and scaling. Monitoring and scaling. How does this do scaling? By doing monitoring. And for monitoring, what you need a monitoring agent, which is metric server. Then only you can do scaling. Okay, scaling means what? Increasing or decreasing the number of replicas of the pod based on the usage of CPU and memory. So basically, in order to do the monitoring, it has to have a installation of metric server, and from that only it can basically get the information, and it can do the scaling accordingly. So let's say the CPU percentage is increasing or exceeding at particular pod, and another pod is having utility, like it can bear the amount of CPU, but it is underused. Then it can shift the CPU utility, or you can have maximum replicas count will be there. Okay, that we have seen right in the earlier videos, that replicas count also can have like more, you can keep like okay, up to this much percentage the number of replicas can increase. So that way also there can be increased, and in the deployments, let's say 3, and currently only 2 pods are running, and maximum replicas count it can have is 3. So HPA can, since the load is increasing on these two, HPA can increase the number of replicas. Minimum is 1. If it is underused, it can reduce the pods to 1 only. So based on that only the HPA will be working. Okay, now that you have seen how this is working, so let me draw a map here, like a simple map. Okay, so first from a container or some container runtimes, Docker, etc., or cAdvisor, the kubelet will get the information of CPU and memory of that particular pod and inside the containers and all. So now kubelets will expose that to particular summary or some endpoint. It will expose like that. Some set of kubelets exposed the data to endpoints, and collectively it collects and places via API service. Metric server will expose collective information, and at that particular endpoint, so that any server, right, APIs, Cube API server is there, right? So here through Cube API server only HPA will communicate, and it will ask like, okay, for every 15 seconds it will ask, please give me, so that I have to do the scaling. So it will get from the metric server on this particular endpoint. Okay, it gets a collective information. Accordingly, it will scale up or scale down number of pods. So that is how it will work, and this is about the HPA concept wise. And if you want to create a HPA, you can either create using imperative command, or you can use a imperative command, or you can use a YAML file. So if you see the imperative command, it will be like autoscale deployment. Okay, kubectl autoscale. Basically you will be having an autoscaler as a deployment. Even the what you say, this metric server is also a deployment only. Okay, and even you HPA horizontal pod autoscaler also will be as a, you will write as a autoscaler deployment, sorry, autoscale deployment. You will have this command in Kubernetes documentation. So, and then you will give some name and hyphen CPU, or you can just do kubectl autoscale hyphen help. You will have the options how to create HPA. Now the thing is that using so min is equals to 1 and max equals to 10. That means you can auto scale up to the 10 replicas, or you can minimum is 1 replica, maximum is 10 replicas you can do for a particular deployment, is what they are telling. That is what they are mentioning. We will see how we can implement, or what are the differences between what we learned and what we are really implementing. We'll see that. But I want to mention one thing. If you are using an imperative command, there is only one resource you can mention, that is CPU only. And if you want to mention memory usage also, then you have to use a YAML file only to create a horizontal pod autoscaler. So for that, what you have to do, you can do like hyphen dry run equals to client hyphen o YAML greater than I'll write it clearly. So you can write like hyphen dry run equals to client hyphen o YAML greater than something HPA1 dot YAML, and then you can do vi HPA1 dot YAML, and inside this you can edit it for memory things. for editing, for memory, etc. So this is all what is about HPA and metric server, what every how. So we have seen in this section like what are differences between HPA and VPA, and how does it calculate, and which are important in creating HPA, and how does actual flow happens between HPA and metric server. Why should we install the metric server? And you might get this doubt as well, like why don't we ask the Kubelet directly from the HPA? One issue is the security issues, and second is that it will be difficult for HPA to know individually for all the nodes which it has to scale. Every time it has to do many calls to each kubelet. So that is one disadvantage if you directly want to use the HPA, and due to the security issues it will not allow. Even though if you have no security issues also, many API calls will happen. Okay, so that is one thing. Second thing, you might get the doubt, why can't we actually use this is fine, HPA to Kubeapi server is fine. Why can't we use Kubeapi server to directly poll for the kubelet stat summary? And here also there is no security issue, but the thing is there will be more load on the Kubeapi server, because Kubeapi server is already maintaining different resources, control managers, schedulers, everything, like it is managing, and on top of that it has to get the monitoring related information also. It will be like more load, right? That's why we don't use QAPI server to directly involve in the monitoring actions. Instead we will install a monitoring service that will do the work for it. I hope this video is clear for you as it covered the HPA related topic. Thank you so much. Bye bye.